I'm so happy to see still so many faces here at the event. This is the closing slot, and 1 more hour to go before we get into the socializing part of the event. I'm happy that, well, this is my 3rd time in Porto, 2nd time this year. I'm quite happy to be back in Portugal. And is anyone here for the first time at Porto Tech Hub? Yes, perfect. Half of you, great. And well, we're having so far a very good time. So the topic that I have for you today is called Going Beyond ORMs. And before I get exactly into the topic, who really enjoys working with ORMs? Oh, there's almost no hands, so you might be at the right place. And this talk is not about to talk trash about that particular piece of technologies. I believe ORMs do have a space in our daily work, especially when you have to talk to databases and data sources. It's just that there may be alternatives or some of the things that you can complement with when using ORMs, right? So my name is Andres Almiray, and Mexican Colombian living in Switzerland. I work for Oracle as a senior principal product manager on the database group. So one of the things that I like to do is just go around the world, talk about the different experiences that I have had as a developer. And I talk about commercial source, closed source, but most importantly, open source. Now, the things that I'm going to see today are not necessarily fully open source, but they are free for consumption, which is kind of a good thing. Now, I hope that what you see today, you will encounter some new things, some things that will inspire you to test out once you go back to the office or when you go back to work in the following days. So, the agenda for today is this one. We're going to start what is the current state. We're talking with data sources and databases, and then using relational data. Then we're going to jump into documents because, well, in the web, the lingua franca, or at least the format that we mostly use to interact with is JSON. Does anyone remember the time when we used to send XML? POCs, right? Plain old XML. Some web services still use it, especially if you deal with banks. Regulations, I guess, is hard to change things. But nowadays, we use JSON. Now, the thing is that when you are using relational and JSON, you need to translate data back and forth, and that can get a little bit troublesome. So the feature that I'm going to showcase today is one option to make things easier. And that feature is known as JSON Relational Duality Views, and there's going to be a demo. Okay, so I'm going to talk about a little bit about the Oracle database. I know there are many different options out there. Apologies in advance because some of the slides are in white, so it might be like barely flash on your eyes. It's only a handful of them. Most of them are dark. And the Oracle database is one of the many options that you have out there to deal with relational data. But it's not just relational data. In case that you didn't know, the Oracle database and Postgres, and MySQL, and Mongo, and other database vendors offer something known as the multi-model option, which lets you store data in different formats under the same database engine. So in the case of the Oracle database, I believe this is the product that offers the most different formats. It's up to you if you need all of them. So you have relational and XML and documents and column-based, even vectors, because everybody's doing AI these days. So the latest version of the database is called 23 AI, released in May of this year. And this allows you to use all these different formats all together. Now, I say this not just because I'm an Oracle employee, but as a developer, it excites me to use this kind of a product. We call it the Convergence database. Because not only does it allow you to store data in different formats in the same database engine, you can use a single query across the different formats. You can use a JSON projection on properties alongside a relational table and a graph and a vector all set together at the database level, instead of doing this at the application level, which of course you can do. Now the difference here is that if you were to do it at the application layer, you have to use different drivers, different libraries, different frameworks to access each different format by separate and then put things together. If you do this at the database level, then the database is taking care of that complexity and the mapping. Now, we also offer, hold on a second, we also offer other options to talk to this particular database. There are tools that are free. There are tools that are open source. I'm going to showcase SQL which is a command line tool to connect to the database, but of course you can use your favorite client of choice to connect to the Oracle database. Now, let's say that we want to model or create an application that models the conference that we have here. So you could start by defining domain objects for some of the entities that we can identify. So there should be an attendee, there should be a speaker, there should be a room, we should have some sort of a schedule which matches together speakers and sessions and rooms and so forth and so forth and so forth. So you can have properties of each one of these entities, and you have relationships, one-to-one, one-to-many, many-to-many. As you know, this is the particular thing that we do when we start to deal with relational data. Okay, so which one of these will have properties and IDs and references, and we can go crazy with this and normalize the data, yada, yada, yada. We know this by heart because this has been going on for what, around to 40 years now? Okay, so the good thing about using relational data in this way is that given that if we have good experience dealing with abstracting the real world into these kind of models, then the pieces fall into place nicely and a little bit quickly. The problem that we face with this thing is that we had to make a lot of choices early on. We had to make a lot of design. If we make our relationships in a bad form, and if we got to production, at some point we say, oh, we made a mistake, we have to update things. We don't want to have any downtime for our current clients. What are we going to do? Are we going to do table migrations? How we do it? How we ensure that nothing wrong happens? And there are so many other things that we have to take care of if we had not done the design early on, right? So it's a bit of a balancing act here. Is how much work we put up front in order to do things right at the beginning, or how much work we have to do later in order to try to fix these perhaps shortcomings or requirements that were not clear early on, because we know that we always get the requirements correct on the first try from our customers, right? Yes, of course. So, yeah, and who likes to work with SQL directly? Let's see some hands, a few hands. Now, ORMs exist in order to do the mapping within what is the raw access to the database, which is typically to SQL, and our programming languages of choice. ORMs were not designed to let go completely of SQL. So this is kind of like one of the misconceptions that I had it as a developer, which is I don't want to talk to SQL because SQL is not a programming language. It's something that is extremely typed. I don't have any type inference. I don't have any type strict types and whatnot. So SQL is ugly. Why do I use uppercase and lowercase? I would rather use Java or Go or Rust or my language of choice, even though maybe not JavaScript. So yeah, ORMs are not necessarily a way to say completely hide SQL because we don't like it and it's ugly. It's just a way for you to do things easier and quicker with your language of choice. All right. So if we wanted to create an application like this that consumes the entities, as many as you may have, we started with an attendee and a speaker, a session, and there may be some sort of mapping within what is a session and the speaker. We want to create a schedule that looks like this. So we grab the data from as many tables as possible, navigating the relationships and consuming the different properties, and voila, we get some sort of an application implemented with any front-end technology that you want. Now, ideally, what we would love to have is just a quick and effortless way to just grab the data and just shove it directly to the client. And if the client says, hey, I have more data that I want you to store, just give it to me at the application and just send it directly to the database. We don't want any of that complexity of what format do you have here? Do I need to translate and map and massage that data so now the browser and the mobile will be able to understand it? And if the mobile sends me JSON or XML or some other, I don't know, whatever proprietary format, then also go back and translate that into something that the database can understand. We want to have that kind of simplicity. Well, JSON documents are capable of giving us that kind of simplicity. If we use a JSON document to describe the set of entities with certain relationships, we could do something like this. For example, at the root of the document, we can define that is the attendee, and then we have nested elements for a session and for a speaker. Now, you will notice that the name of the speaker here is nested at the same level as the properties of the session. So instead of being 2 levels, we're actually, or actually 3 levels, it's actually 2 levels, and somehow the application will know that you had properties of 2 different entities mixed together. That's one possibility, because with documents, we can create our own schema and evolve it as we need it. So the same entities, the same data, can be represented with a different schema, in a different structure, different document, same data. We could have the session be the root, and now have both the speaker and the attendee have their properties mixed together. Or we can have just 2 elements like this. The root will be the speaker, and then we have the session, right? It's up to us. The advantage is, no matter how this thing was stored in the database, we can create different representations in terms of a structure of the same data. Right. So JSON documents. All the information is right there. Did I show something about the references and the IDs and primary keys and foreign keys and constraints, all that? No, because we are just consuming the data as we need, as we as humans can understand it. But of course, the computers can understand these formats as well. So documents are very good to express the data that we can read very easily. Now, we don't have to have these IDs and references. These schemas are flexible. We can move things as we need it. It doesn't matter how the data is structured down there. We can create as many different variations of documents as the consumers will require them. So that's a pretty good thing. Perfect. Now, the one possible problem that we will find is that when we have nested elements, we will encounter this thing of duplicate data. So for a speaker that has 2 different sessions, and if the way that we put things together, let's say we have a room with a speaker and a session, then we see it's just the data for that. But when we see yet another room and there's the same speaker with a different session, at least the data of the speaker, when we represent the whole conference, will be duplicated. And if we look at all the different information for a single room for all the whole day, the information in the room will be duplicated, right? That's not good in terms of data normalization when we look into relational terms, but it's okay in documents. Now, if we want to get rid of that duplication in JSON, well, we can attempt doing normalization of JSON documents. Has someone tried that? All right, no hands. Good. Because say, for example, we start with a document that looks like that on that far side of the screen that contains all the information, and then we start to add IDs for the different entities. So now we can get different fragments of the same document, and more fragments, and more fragments. From the point of view of the data, same data. From the point of view of the document, now we have multiple documents. Is it easier now for us humans to understand this side of the data? It starts to get harder. And as you add more entities, as you add more data and more complexity to your model, understanding this on your own will be really, really hard. Whereas if you were to look at just one single document, when you have everything that comprises that particular use case, it perhaps gets easier, right? So, when you normalize documents, the simplicity of JSON is lost. If someone comes to you at your team and say, hey, I have a really nice idea. I know we have to deal with JSON documents and there's relational data, and I don't like the duplication of the data because we're sending too much information across the wire, and maybe there's an SLA about the time and response and all that. Let's go crazy and normalize the document. Don't go that way. That is the wrong way to do things. There are different options to get around this problem. Because what ends up happening now is that if you were to do that, then your documents are pretty much a JSON view of a relational table with all those IDs, and now someone has to take care of managing the relationships and the IDs. And guess who someone's going to be? It's going to be you, or it's going to be someone in your team. It's not going to be an ORM. It's not going to be a library. Someone has to write that piece of code. So we end up getting the worst of both worlds. We get data normalization and IDs and reference and whatnot, and fragments of JSON documents. Yeah, not good. JSON is pretty good to get started quickly, right? So we can create a JSON document with any kind of structure that you want, and we can change it on the fly as needed. The good thing is that, again, it doesn't matter how the data is stored here, we can change things as we go, depending on this screen, or this other screen, or this page, or this other mobile client. So that's pretty good. But once the application continues to grow in complexity, keeping up with as many different variations of a document may be troublesome, may be tiresome. Now, in the case of relational, as said, when you start with a relational world, you have to create the schema up front. You have to define the relationships. You have to do a lot of work early on, which means when you start, there's a lot of things that have to happen. The way that you develop the application is a bit slow. But once the complexity of the application grows, then you see the benefits of doing this early on. And you get reporting, and you get so many of the tools that already understand the relational world. So as your application continues to grow and has a very long lifetime, then doing relational things works. Now, can we mix these things together? Can we have the speed and the agility and the flexibility of JSON documents early on in our application where we're doing experiments perhaps? We have to have that time to market as soon as possible. But can we also have the reliability of having relational data? Well, this is exactly what we propose with this feature called the JSON Relational Duality View. The idea is that you can start with either relational or documents, and you switch between one another effortlessly. This does not mean having a copy of data in a relational way and having a copy of data in a document way. You only have one copy of the data, and you expose it through relational or through document to the outside world, but you also take in data through the relational way or through the document way. And again, everything goes into just one instance, one storage of the same data. Now, this is what we call the JSON Relational Duality View. And we will start by storing in relational way. And what we want to do is expose the data through the two ways, relational or document, so that someone has to create a mapping between the relational world and the document world. That someone is the database engine. And we can do it in two ways. We can provide a JSON mapping or a GraphQL mapping. I prefer to choose to show the GraphQL mapping because it's easier to read. And so what we're seeing here is a mapping when we say, given an attendee, which is the root of my document, and will express some requirement for some of the properties, columns and properties, and I have a nested element to the sessions, and a nested element for the session, and a nested element for the speaker. If I have this and provide this to the database, every time that I want to query how many tables, attendee, session, speaker, and the mapping table, which is attendee session, so I'm querying 4 tables at the same time, and I'm exposing that as a single JSON document, which has this structure. So given that I am in charge of defining the structure, I can create things in a different way. If I want to have the speaker be at the root or the session or something else, it's up to you. Now, how does this work? You notice that there are some names here that match the relational tables that we have defined. So there's attendee, attendee sessions, session, and a speaker. We also have the names of the columns. So what we have on this side, these are the names of the JSON properties we want to have in a document. So underscore ID, name, company, and these are the names of the relational columns we want to expose. Then we have here a relationship, with a mapping table, and we're saying that whenever someone gives me a document that contains an attendee at the beginning, and if I happen to have a relationship to schedules, then I'm going to either insert or update the given relationship. That means I will either update an existing attendee or insert a new one, but every other element that I have here must exist already. So that means when I insert an attendee, I'm not going to insert a session or insert a speaker. I'm just going to insert their relationship. And if I delete an attendee given a document, then I'm going to cut their relationship, and I'm going to delete the rows that match the attendee, but I'm not going to delete the session because there may be another attendee that has access to that particular session, right? The other thing that I can say with this annotation on nest is that the properties of the speaker, which are 2 levels down, I'm going to lift them 1 level up such that this property will look like it belongs to the session. So I will have a property named speaker with the value of this column in the table speaker, and this property will be seen here at the level of the session. Okay. So we ended up having pretty much a document that looks like this, given that particular GraphQL mapping that we saw. And the advantage of these kind of mappings is that you can make it as small, as big as you want, and you can query as many tables as needed. You can query just one and expose all the properties if you want to, or just a handful. So because it depends on the use case that you have at hand. Now, you can use 2 different kind of APIs to work with these views. You can use regular SQL, or you can use document APIs to talk directly to the database. So in the case of SQL, notice that we have it's not a keyword, but this is the name of a column. So my relational table is S. I have a column called data, which represents the JSON document. And from that document, I can navigate the relationships. So I'm here now querying just the first level property. But if I wanted to go 1 level inside or as many levels inside in the properties, then I can certainly do that. Now, why are we building these things? How many of you are running web applications or microservices? Yes, more than half of you. And most of the times you're using JSON, right? And most of the times you're using REST APIs to do this. And what are we doing? In the end of the day, our job is to grab data from a data source and change the pixels on a screen. And once we get some additional pixels, we put that data back into the data store, right? So it's basically this kind of simplified workflow. It doesn't matter what kind of framework you use to build the application, Quarkus, Spring Boot, Micronaut, Helidon, what have you. We would like to have some sort of REST API from which we can grab data from the data source or store data in the data source. So we have this. Now, if we are sending data here, where is our client here? If we're sending data in JSON format to the database, or if we're retrieving data in JSON format to the client, why do I need to have the access to, say, for example, JSON or JSON, so that I can map a string, which is my document, JSON, into Java objects, and then somehow get those Java objects shoved into some SQL so that gets directly sent to the database? Why do we have to go through these complexities, so many different pieces to make this work? Again, is the ORM kind of does a good job here, but perhaps it's too much. And the same goes on the other way around when we want to retrieve that data. Here we have the representation in relational way, and then map it into Java objects, which eventually will just get mapped into a big document in a string that gets sent to the client. Now, we can go quickly to these things, because there are some advantages of using this, which is if we let the database do the mapping for us, then we don't have to go through the optimized binary format, which the databases use to store JSON. So Postgres, MySQL, Mongo, and Oracle use different ways to store JSON. They can store it in a character way, or they can use it in a binary way. There are many different variations. One of my teammates have a really nice YouTube video explaining the differences within the different binary formats of these database vendors. Obviously, Oracle has its own format, which has been defined to optimize for certain use cases. The other vendors provide other optimizations as well. So I invite you to do your own research on the different binary formats. So the thing is that if we want to read that data in binary format, and then we translate it into an object graph of Java types, and then translate that into a big string of characters, then we're just wasting time doing these old transformations. If we're able to grab the binary data and just send it directly to the client with a quick, effortless character transformation without having to do these things in between, then technically we should have better performance, right? Okay, so in order to make this work, you will need a particular version of the database. For now, this feature is available only for the Oracle database. We are the ones that are starting, we are spared here in this particular feature. But it's our hope that as developers continue to discover this feature and use this feature, then perhaps other database vendors will also embrace this particular feature. I say this early on because one of the questions that I get asked on this talk that I've given a couple of times is this thing first, is open source, and second, is this available on Postgres or MySQL or the other vendors? So not yet, but it's our hopes that it will maybe become something like this, maybe even part of the SQL standard. We'll see, no promises. So in order to run this, again, white, you can use the latest version of the database, which is called 23AI. And there is a version, you will see these QR codes where you can navigate to the different URLs. In case you didn't know, this version of the database was released for us developers first, before than everybody else in April of last year. And this version of the database has a different license, the free use terms and conditions, which allows you to run this database, this version, which is the full product, on development, on testing, and on production for free, the full product. And you can run it on Linux, you can run it on Windows, Intel, and since September of this year, you can also run it on ARM Linux, and since 2 weeks ago, which we made the announcement at KubeCon, you can also run it on Mac ARM. So pretty much running everywhere. And if for some reason that will not be the case for you, you don't have the right platform, well, you can also run it on the cloud. It's the autonomous version, for which if you go to oracle.com/cloud/free, you can sign up for a free tier, which is always free. We don't charge you anything. You use it forever. You have access to 2 instances of the full product with plenty of space. And if that wasn't enough, which is this thing that I'm telling you about, the cloud free tier, you can also run it on containers. You can run the cloud version, this one, or you can run the on-premise version free. You have options to other images. There is OCI Oracle Free. This one has less memory footprint. It has like 900 megabytes, and it starts in 10 seconds, within 3 to 10 seconds. And that's version 23. This is the version you want to use for JSON Relational Duality View. But if you, for whatever reason, you need access to previous versions of Oracle, then you can also use Oracle XC, which is also available for free in development, testing, and production. All right. Who uses test containers? Just a few hands. Okay. 2 things I want you to take away from this session. 1, you can use the Oracle database for free in all deployments and all environments. And second, if you are testing applications and you require access to databases or real software, have a look at test containers. Test containers is a technology that allows you to run any software that can be containerized. And once you set up your test cases in such a way that it allows you to bootstrap this software that you need, a database, or Kafka, or RabbitMQ, what have you, whatever can run on a container, before your application runs, or before your test runs, and then the test runs, you do whatever you need to do, the assertions. Whether the test is successful or not, test containers will take care of cleaning up resources for you. So there's nothing that gets lingering. The advantage of this is that gone are the days where you had to ring someone from IT and say, hey, can you provision me such and such software with that version and blah, blah, blah. And then 3 months later, you get an answer that said, no, sorry, I couldn't. Or that you have to have a dedicated server that you cannot share with anyone. And you have to ensure that it has the right version and the right admin and that you have the right state before you run your test cases. And now that we have CI and CD, how are you going to share that with your teammates and the server? Things can start to get complicated. Well, test container says, forget about that complexity. Every time that you want to run a test case, I'm going to supply a brand new, pristine environment where all the software that you need is ready for you to be run, and your test case runs and connects to that. Isn't that great? That's what I'm saying. Test containers is a game changer. So test containers offers many modules that allows you to connect to specific pieces of software. You can connect to pretty much every database that exists out there. Doesn't matter if it's relational or not. And obviously, there is a module explicitly for Oracle Free. Once you define dependency on your Maven POM or your Gradle build file, you will have access to a new class called Oracle Container. Supply the name of an image that you want to use. It could be the ones from Oracle Free or the official ones from the Oracle Registry or any other image that you build, and then just start the container, and boom, you're in business. Okay? So now I'm going to show you a demo. We have time for this. I have a very trivial application has been written using the Micronaut framework. Who uses Micronaut? Okay, one hand. Who uses a Spring Boot? I expect 70% of you, most of you. Anyone here uses Quarkus? A few hands. Helidon? No? Any other Java, Jakarta EE technologies, enterprise Java? All right, perfect. So what I like about Spring and Micronaut and Quarkus and enterprise Java is that even though they have their own individualities, many of the concepts are shared across the different frameworks. Some of the annotations and the base classes have the same names, and some others may be different, but the way that you learn how to use one framework can be translated into another. So even though I'm going to show Micronaut, if you know Spring, you should be able to find your place around very quickly. So just like a Spring data, we have in Micronaut something called Micronaut data. And in Micronaut, I can define, for example, I'm going to make this a little bit bigger. Here I have an entity using the Micronaut data annotations. Again, different names, but the same ideas behind this. So I can have the name of my table, which is a student, and then some properties, an ID, and here's the join table within my student and my classes. I have a mapping with classes. When I look at the classes, or could have been perhaps named as course. It's just that. Another very trivial domain entity. So I have only 4 domain entities here. I have class, a student, teacher, and the mapping table, which is a student class here. Okay. Just like in Spring Boot, I have access to repositories, which are interfaces that give me access to the CRUD operations that I want to have on a particular entity. In the case of the class repository, it will be just the classes, and I can define my own additional finders and queries. You know this by heart because you know Spring data. Now, in the case, and we also have controllers, just like in the other frameworks, which are the ones that are going to expose behavior through REST endpoints. In the use GET, or in the Spring Boot, you can use request mapping or some different annotations, but the idea is basically the same. Now, what is different here is that besides the schema, that we use just regular DDL here to define the tables that map the names of the tables and the names of all the properties like name, average, grade, room, class ID, all these things that map to the properties that we define in our Java classes. I prefer to define the DDL directly instead of, yes, I know that the ORM can generate the DDL for me. I'm also using Flyway to add an additional script here You might recall that I mentioned for JSON duality views, I can have a JSON format. Here's a duality view defining the JSON format, which is kind of verbose. And here is a JSON duality view using the GraphQL format, which in my perspective is a little bit more readable. This representation is quite similar to what I show in the slides. So we have a student, which is the root, and we have a mapping table with the classes. The teacher is again also nested inside each one of the classes. We're going to lift the properties of the teacher into the classes so that when you look at a document generated from this duality view, we have a student and a list of elements that contain all the different properties. Okay. What else do we have? Let's look into the student repository, which is a repository that works, again, with the ORM that allow me to query all different kind of things that I can do with a student domain entity. But I can define my own custom finders just with regular SQL. And I'm here now defining another finder just to showcase that I can. It doesn't mean that I should. Because this thing, what I'm doing here, is a simple update. But I'm doing it so using a document API. Look, it's just regular SQL. We're going to update to the JSON duality view, and we're using the data column and some JSON transformation to change a fragment of my document. This eventually gets mapped into a trivial update statement in SQL. So this is overkill. Don't do this. I'm just saying you can. Doesn't mean you should. Here is another way, for example, where we're going to find one element by an ID or by a name. Again, these finders, they already work for SQL. But what I get as a result from the repository is what? A student object, a Java object that eventually needs to get translated into JSON to go directly to the client, right? What is the return type here? A string. This means the database is returning directly the JSON document that matches my query. And I can send that JSON document directly to the client. There is no in-between transformation anymore. So the rest of the query is here. Here's to find everything. Here's how to delete. We find doing a calculation. And just because I can, here's how I can do a insert or create a new object. Now, the thing is that this particular JSON document does not match the mapping that I find in GraphQL. How did I know? Because the list of sessions contain just the names of the classes. But for in the document to be stored in the database, it has to match the mappings. And the mapping says I had to have a full-blown class object with all the properties that you want. If you give me just the name, then I will not understand it and I'm going to fail. So that being said, long explanation making short, when we look into the controller, look, I query one object, one student by an ID. I go through the JSON document, the JSON duality view, which gives me a document if it's found, and I just return it. There is no additional transformation here. If there's a document, it gets sent directly to the client. I find all of them, all the possible students, and I get a list of a string that gets translated into a single document, and there it goes, boom. Or I find a student by name, and again, it returns a JSON document as is. Do I want to update? Here's one option. When I use the regular ORM, so this is using a Spring Micronaut data. And this is what we usually want when we use ORMs. We want to use our programming language. So here are all Java entities. So we set the properties, we store to the repository, and then we return an object, a Java object, which is a student, get this mapped through JSON into a JSON document. But if we were to do this through the JSON duality view, we get the data, we use the repository, and the result here is we're returning here the student to be compatible in terms of behavior. I'm not returning a document. Let me show you a place where we're returning a document. I don't think we do. So let's show the one for create. Here's the regular way using Micronaut data with the ORM. Again, just regular classes, returns a student object. And here's a way using the JSON Duality View. You give it a payload. This is the input document. Send it to the database directly. If it matches the mappings, then we're going to store it and then just return. Here, if we are successful to store the object that gets sent back into SQL, we eventually get a Java object that gets translated back into JSON so that I can send it back to the client. All right, so I'm going to run the application. Let's see. Open this. Oh, before I run it, I have to run the database. So I have Docker. I have my database already set up here. And this container should start pretty quickly. There we go. It starts about 10 seconds or so. It says database ready. Not yet. There we go. Database is ready. So now I can run my application. Run it. And once it run it, I can do some queries. I think that I have here in the README. I can show something. For example, I already had the database initialized. And let's clear this, and I can make it a bit bigger. And I can say, issue a query to the application, and use JQ because I'm going to get a list of documents. Here we go. This is the relational data using the final through the JSON Duality View, which is the same as if I were to do here, let's say, show me, obviously I disconnected from the running container, so I need to connect again. SQL here is actually SQL is a free tool that we offer to connect to Oracle databases. And so now I can finally do this. Here I have the list of all the students, all the names. So if we look into the document, someone should be there. There is Peter with ID 4, and then there's Fred with ID 3, Fred with ID 3, and Peter with ID 4. Great. So that works. So if I want to query just one of them, let's do number 3 instead of number 1. So let's go into a terminal and do number 3, which should be Peter, right? Because it's Fred. It's actually Fred. And give us that document. Okay, so that's pretty good. Let's see, what else can we do? Shall we try inserting a new one? I think this is the reason. I'm going to show you why I did this tricky thing here. I'm going to post this. I'm going to change, instead of Dallas, this should be Porto. And we're going to give it a perfect grade. And math and English. So this is the reason why I need that transformation. If you supply a correct document, then you don't have to do the things that I showed you in the repository. Okay, so here we go. Boom. We get a new document. Let's query all the students. Let's use that query that we saw earlier. Here's a new student. And if we do the query on the relational way, there's a student. So the same data being accessed in 2 different ways. Now, the complexity of doing those transformations with the data is just one, in this case, one single mapping, which is the JSON Duality View. All right. All right, let's go back to the slides. So everything that you saw today, you can try it for free. I have some resources for you. The first one would be, if you want to try the version of the database on the cloud, is this link. If you want to try the database on-premise, so you can use it again, Linux, Windows, or Mac, Intel, and ARM, is this one. If you want to know about additional software that Oracle produces for free, it's not just the database, but Linux and Java and whatnot, completely available for free for developers, go to this website. And if you want to try out all these different technologies on the cloud, again, for free, we have an option for online workshops that you can run on your own pace at your own time. And we have Quarkus and Micronaut and Spring and Growl and Database and Oracle Apex and so many different things happening here, all readily available to you. So this is basically it. We believe that this feature really changes the game. We're not saying kick your ORMs to the curb. We don't need them. The application that I show here, I still use ORMs for the regular CRUD operations. But I will use the JSON Duality Views when I want to combine more data through different tables. Can you use JSON Duality Views for CRUD? Yes, you can. Just that you will have to define one mapping for each one of the tables that you want to do CRUD for. Now, this is one of the things that ORMs can do pretty well because they've been doing it for years. But if you want to have additional conversions within what is JSON and relational, and perhaps in the future will support other formats, then give JSON Relational Duality Views a try. Now, this is everything that I have for you. I hope that you really take home this feature and also test containers so that you can have a much better experience when developing applications that are connected to databases. If you have any questions, I'll be very happy to answer them. If not, then I thank you very much for your time, and I hope to see you again next year at the next edition of Porto Tech Hub. All right. Thank you.